Now let's say that r is equal to 2 sine theta and r is also equal to 1. So there's two different curves. Find the area of the shaded region that lies inside the first curve and outside the second curve. So let's draw a picture. So the first curve looks like this. R equals 2 sine theta. And I'm going to draw that in red. It's basically a circle, and it has a diameter of 2. So at this point here, the r value is 2. Now the other one, r equals 1, it's also a circle with a radius of 1, but it's centered at the origin. So this is 1, and this is negative 1, and that's negative 1. And this point is 1 right here. Now, what area, which shaded region are we looking for? Are we looking for this shaded region, or are we looking for this region? What would you say? So looking at the problem, it says we need to find the area of the shaded region that lies inside the first curve. So it's not this region here, because that's outside the first curve, which is the red curve. It's inside the first curve, but outside of the second. It can't be here because this is still inside of the second curve. So it has to be this region. It's in the first curve, but it's not in the second curve. So how can we find the area of that shaded region? First, we need to find the points of intersection. So what are the theta values that correspond to those points of intersection? How can we find it? What we need to do is set these two equations equal to each other and solve for theta. So r equals r, and therefore 1 is equal to 2 sine theta. Dividing by 2, we have 1/2 is sine theta. Now, for what angles is sine equal to 1/2? So sine is positive 1/2 in quadrants 1 and 2. And theta is going to be pi over 6 and 5 pi over 6. Sine pi over 6 is 1/2, and sine 5 pi over 6 is also 1/2. So what we're going to do is we're going to integrate from pi over 6 to 5 pi over 6. And that's going to give us the area of the shaded region. Now, when finding the area of the shaded region in polar coordinates or in polar form, you can use this equation. It's the integral from alpha to beta 1/2 r squared d theta, where r is a function of theta. So you could write it this way: 1/2 f of theta squared d theta. But when you have two curves, you need to deal with another r value, which we'll call g of theta. Let's call this r1 and r2. So you can write it this way if you want. So the area between two curves is going to be the integral from alpha to beta 1/2, and then f of theta squared minus g squared of theta d theta. Or if you prefer, you can write it this way: 1/2 r1 squared minus r2 squared d theta. I prefer it that way because there's just less to write. So now let's get our answers. So alpha is pi over 6, beta is 5 pi over 6, and then it's 1/2 r1 squared, so that's 2 sine theta squared, and r2 is 1, and then d theta. So this is going to be 1/2 of 2 squared is 4, so we're going to have 4 sine squared theta minus 1, and then d theta. And let's move the 1/2 to the front. So now it's just 4 sine squared theta minus 1. Now we need to use the power reducing formulas. And if you recall, sine squared theta is 1/2 times 1 minus cosine 2 theta. So this is going to be 4 times 1/2 times 1 minus cosine 2 theta, and then minus 1. So 4 times 1/2 is 2. And then what we need to do is distribute this 2 to 1 and negative cosine 2 theta. So it's going to be 2 minus 2 cosine 2 theta minus 1. And then we can combine 2 and negative 1. So now we have 1/2 the integral from pi over 6 to 5 pi over 6. And then this is going to be positive 1 minus 2 cosine 2 theta d theta. And so that's equal to the area. So let's go ahead and integrate this thing. So it's going to be 1/2. The antiderivative of 1 d theta is going to be theta. And the antiderivative of cosine is sine. So for cosine 2 theta, it's going to be sine 2 theta divided by 2. Evaluated from pi over 6 to 5 pi over 6. And so we could cancel 2. And so now it's going to be 1/2. If we plug in 5 pi over 6, we're going to get this, and then minus sine 2 theta. So 2 times 5 pi over 6, that's 10 pi over 6. And 10 pi over 6 reduces to 5 pi over 3. So we're going to have sine 5 pi over 3. And then it's going to be minus pi over 6, and then minus 2 times pi over 6 is pi over 3. So sine pi over 3. So this is going to be 1/2. And then we can combine 5 pi over 6 minus pi over 6. So that's 4 pi over 6, which reduces to 2 pi over 3. Now sine 5 pi over 3. Sine pi over 3 is the square root of 3 over 2. But 5 pi over 3 is in quadrant 4. So this is going to be negative square root 3 over 2. And then we have minus. I've already incorporated that into this answer. And then we have negative sine pi over 3. And sine pi over 3 is positive square root 3 over 2. So this is 1/2 2 pi over 3. And then plus the square root of 3 over 2 plus another square root 3 over 2. The square root of 3 over 2 plus another square root 3 over 2, that's going to be 2 square root 3 over 2, which is just the square root of 3. Now what I'm going to do is get common denominators, so I'm going to multiply the square root of 3 by 3 over 3. And so I'm going to get 1/2 times 2 pi over 3 plus 3 root 3 over 3. And so this becomes 1/2. Now I can write it as a single fraction, 2 pi plus 3 square root 3 over 3. And so the final answer becomes 2 pi plus 3 square root 3 divided by 6. Now let's go ahead and get the decimal answer for that value. So this is equal to 1.913223. But this is the exact answer if you want it like that. Or if you want the decimal answer, that's it. Now let's work on a similar problem. So this time, the first curve is going to be r is equal to 3 cosine theta. And the second curve is r, let's call this r2, that's going to be 1 plus cosine theta. So go ahead and graph these two polar equations and find the area of the shaded region that lies inside the first curve and outside the second curve. So the first one, 3 cosine theta, is a circle that points towards the right. It looks something like that. Let me see if I can draw a better circle. Now the second one looks something like this. I'm going to draw it in green. So we want to find the area of the shaded region that lies inside the first curve, but not inside the second curve, outside of the second curve. So it's going to be between the two curves in this region. Just like before, we need to find the points of intersection. So how can we find that point and this one as well? So we need to set r1 equal to r2. And so we're going to say 1 plus cosine theta. Well, r1 is 3 cosine theta. And that's going to equal r2, which is 1 plus cosine theta. Subtracting both sides by cosine theta, we have 2 cosine theta is equal to 1. And dividing both sides by 2, we can see that cosine is 1/2. Now, what angles will cosine theta be 1/2? Cosine is positive in quadrants 1 and 4. And the reference angle is going to be pi over 3. So cosine pi over 3 is 1/2, and cosine 5 pi over 3 is also 1/2. Now let's write the formula that we need to get the area. So it's going to be from alpha to beta, and it's 1/2 r1 squared minus r2 squared d theta, where r1 is larger compared to r2. So this is going to be r1 because it's further away from the origin. R2 has to be basically the smaller curve because it's closer to the origin. So that's how you need to view it. And that will give you a positive answer. Now the real issue is determining what's alpha and what's beta. So can we say that alpha is 5 pi over 3 and beta is pi over 3? Can we integrate it from 5 pi over 3 to pi over 3? If we do so, notice that this answer is basically equivalent to negative integral pi over 3 to 5 pi over 3. So it's the same as going in, instead of going this direction, but since it's negative, going really in this direction, and there's nothing there. So if you try to integrate it from 5 pi over 3 to pi over 3, you're not going to get the right answer. And that's what you need to be careful with in this problem. So the best thing to do is to start at 0 and go to pi over 3 and double your answer, because there's symmetry in these two graphs. So we're going to say that the area is 2 times the integral from 0 to pi over 3, and then 1/2 r1 squared, so that's 3 cosine theta squared, minus r2 squared, so 1 plus cosine theta squared, and I'm running out of space, d theta. So at this point, we no longer need this information. Three cosine squared, that's going to become 9 cosine squared theta. Now we need to FOIL 1 plus cosine theta times another 1 plus cosine theta. So 1 times 1, that's just going to be 1. And then we have 1 times cosine, cosine times 1, so that's going to be 2 cosine theta. And finally, cosine times cosine, which is cosine squared theta. Now, we could cancel the 2 and the 1/2 out in the front. So the area is going to be the integral from 0 to pi over 3. And then we can combine 9 cosine squared minus cosine squared. So that's 8 cosine squared theta. And then it's going to be minus 2 cosine theta minus 1 d theta. Now let's use the power reducing formula for cosine squared theta. And so that's going to be 1/2 times 1 plus cosine 2 theta. Now we have an 8 in front. So it's 8 times 1/2, which we can make that 4. So it's 4 times 1 plus cosine 2 theta. And distributing that 4, we're going to have 4 plus 4 cosine 2 theta minus 2 cosine theta minus 1. And now we have 4 minus 1, which we can make that 3. The antiderivative of 3 d theta is 3 theta, and the antiderivative of cosine 2 theta is sine 2 theta divided by 2, and the antiderivative of cosine theta is just sine theta. So let's plug in pi over 3. So it's going to be 3 times pi over 3, and then 4 divided by 2 is 2. Now sine 2 theta, so that's sine 2 pi over 3, which is in quadrant 2. Sine is positive in quadrant 2. So that's going to be positive square root 3 over 2. And then minus 2 sine pi over 3. Sine pi over 3 is also the square root of 3 over 2. And then minus 0. 3 times 0 is 0. Sine 2 times 0 is still 0. So everything in this side is 0. So we could cancel these two. And 3 times pi over 3 is pi. So now we have the final answer. The area of the shaded region is equal to pi. And so that's it for this problem. Now let's work on a new problem. Let's say that r is 1 plus 2 cosine theta. Find the area of the shaded region between the loops of the polar equation shown below. So let's begin with a graph. So how can we graph this particular polar equation? So it's going to look something like this. And it's going to have an inner loop. Again, you can check the description section of this video, and I'm going to include some links that tells you how to graph polar equations and how to use an online calculator to do so as well. Now, let's identify the area, the shaded area, between the two loops. So it has to be outside of the inner loop, but inside of the big loop. So it has to be this region. So how can we find the area of this shaded region? What do we need to do? Well, first, we need to understand the angles. So this region here is from 0 to pi over 2. And then we have some angle, which we'll call A and B. So this region is from pi over 2 to some angle A. And notice that A starts when the curve touches the origin. And then it goes from A to B. So it's back at B when it touches the origin. And then from B, it goes to, this is 3 pi over 2, and then back to 2 pi. So how can we find A and B in this example? So A and B, they're at the origin, which means r is 0. So we need to set 1 plus 2 cosine theta equal to 0. Subtracting both sides by 1, we have negative 1 is equal to 2 cosine theta. And dividing both sides by 2, we have cosine is negative 1/2. So cosine is negative 1/2 at 2 pi over 3, which I'm going to put this in red, and at 4 pi over 3. Now, going from this region at A, this is 2 pi over 3, and then making a half of a loop, that's 3 pi over 3, which is pi, and then coming back to make a full loop, it's 4 pi over 3. Now, what I'm going to do is find the area of the top half, and then multiply it by 2. So from the origin, this is going to be R2, because that's the outside part of the curve, and then this part is going to be R1. So it's like R2 squared minus R1 squared. So for the outside curve, which goes from here to this region, we're going from 0 to 2 pi over 3. So the area is going to be the integral from 0 to 2 pi over 3, and that's for R1 squared, 1/2 R1 squared. And R1 is 1 plus 2 cosine theta squared d theta. Now we need to subtract that by the upper half of the inner loop. So for the upper half, it starts at pi, and then it goes to b, which is 4 pi over 3. So it's going to be from pi to 4 pi over 3, and then it's 1/2 R2, which is the same as R. We only have one equation, so 1 plus 2 cosine theta squared d theta. Now, this only gives us the area of this shaded region in yellow, not below the x-axis, just above it. And we only have the upper half of the loop, so therefore we need to multiply our answers by 2. So 2 times 1/2 is 1, so these will cancel. Therefore, we could say that the area of the shaded region is going to be the integral from 0 to 2 pi over 3 of 1 plus 2 cosine theta, rather, squared d theta minus the integral from pi to 4 pi over 3, 1 plus 2 cosine theta squared d theta. And this will give us the answer, which is pi plus 3 square root 3. And if you want the decimal value of that answer, it's approximately 8.337745076. So you know how to evaluate the integral. You can use a calculator if you want to, or you can FOIL it, and then use the power reducing formula on cosine squared, and then just integrate and plug in your numbers. You should get this when it's fully simplified. Or if you want the decimal value, you should get that answer. For the next problem, let's say that R1 is sine theta and R2 is cosine theta. So let's begin with a graph. Now sine theta is a circle centered along the upper y-axis. Cosine theta is a circle centered along the positive x-axis. So the area of the region that lies inside both curves is this area. How can we find it? Well, the first thing we need to do is find the points of intersection. So we know that at this point theta is equal to 0, But what about at this point? Sine 45 and cosine 45, they're both equal to the square root of 2 over 2. And so that's going to be pi over 4. Another way in which you can get the same answer is to set sine equal to cosine. Now let's divide both sides by cosine. On the left, sine divided by cosine is tangent. On the right, cosine over cosine is 1. And tangent 45, or tangent pi over 4, is equal to 1. And so that's another way in which you can get that answer. So how can we set up the integral that will give us the area of the shaded region? So let's draw this one step at a time. Let's focus on the red curve. And let's understand what's going to happen if we integrate from 0 to pi over 4. So what we need to do is draw a line from the origin to pi over 4. And so it's going to give us the shaded region. So at 0, we have a line that, let me draw in green, or rather in yellow. We have a line that extends this way. And at pi over 4, it's this portion. So we're integrating from 0 to pi over 4 to get this area. Now let's focus on the cosine graph. And this is where you need to be careful. Now, if we draw a line from the origin to pi over 4, it will give us this shaded region. So to get this combined region, we need to add up these two values as opposed to subtracting them. Now, what are the angles that we're dealing with for this particular graph in order to get this shaded region? It's not 0. We're not going to go from 0 to pi over 4. So notice that this portion extends to pi over 4. But we're not going to use 0 because if we did use 0, we would get this shaded region, which we don't want. Rather, we need to use pi over 2. So from pi over 4 to pi over 2, that will give us this shaded region. So therefore, we need to set up the integral in this way. So for this region, the area is going to be the integral from alpha to beta, 0 to pi over 4, 1/2 r1 squared. So that's 1/2 sine squared theta d theta. And for this particular region, it's going to be the integral from pi over 4 to pi over 2, 1/2 cosine squared theta d theta. So go ahead and type this in your calculator. The area is going to be the integral from 0 to pi over 4, 1/2 sine squared theta d theta, plus the integral from pi over 4 to pi over 2, 1/2 cosine squared theta d theta. And so you should get pi over 8 minus 1 over 4. And so that's the answer. Or you could write the answer like this if you want to. You could say it's pi minus 2 over 8. And the result is the same. Now the decimal equivalent of those answers is 0.1426990,817. And so that's it for this problem.